Hello, welcome to Instructor Alison Online Tutorials. In this video, we are going to discuss trigonometry. So trigonometry is concerned with the ratios of the sides of triangle. Okay, the knowledge of trigonometry is essential for the study of science and engineering, as many problems are expressed in terms of the trigonometrical ratio. In this section, we will introduce the basic trigonometry ratio and study their properties and application. So one of these property is a triangle. We'll consider a triangle. What do we understand by triangle? It is a plane figure bounded by three straight lines. It's called a triangle. All right, any plane figure that is bounded by three straight lines is called a triangle, and we usually denote this triangle by letters ABC or XYZ or any of the variable you can think of. It is okay, use any one of your choice. So the sum of the angles of a triangle is 180 degrees. All right, so if we have this to be a triangle, we usually indicate it with X, Y, and Z. This is an angle, this is an angle, this is an angle. The sum of this angle is 180 degrees. All right, it is very important you take note of that. Another essential property of this triangle or trigonometry we're going to talk about is right angle triangle. Right angle triangle. And in this concept, if one of the angles of a triangle is a right angle, that is 90 degrees, it's called the hypotenuse. So let's make some sort of example by drawing the right angle triangle. Firstly, if I have this to be right angle triangle, this angle here is 90 degrees. All right, let's say here is angle theta. So if one of the angles of a triangle is a right angle, that is, this particular position is at right angle, we call this side of the triangle or right angle triangle to be the hypotenuse. Hypotenuse. Again, let this particular angle be theta, and this angle is less than this angle, 90 degrees. This side that is facing this angle theta is what we call the opposite. You need to take note of that. Any side facing this angle theta is the opposite, and then the side that lies between this angle 90 degrees and theta is the adjacent. Okay, so it is also very important that if we redraw this right angle triangle, we can as well represent this with A, B, and C, so that if we have here as 90, here is theta, this side that is facing this A is small letter a. Let's represent it with small letter a. The part that is facing this particular angle, this side of the angle, let's represent it facing this capital letter B. Let's make it small letter b. And this other side facing this capital letter C, we can as well make it small letter c. So that is to say, this is corresponding to this, this to this, and this to this. Okay, so we usually remember this size of this triangle, the ratio of the size of this right angle triangle, with an acronym called SOHCAHTOA. SOHCAHTOA. This will help us to define the ratios of these trigonometrical identities. All right. So the first we have here is sine theta. This sine theta is from the acronym opposite over hypotenuse. Opposite over hypotenuse. Let's put it in its short form, which is the same thing as, if you check the ABC parameter, you can see that B is taking the position of opposite and also C is taking the position of hypotenuse. So I can also represent it as B over C. All right. The next one we're going to look into is C, which is cos theta. And this cos theta is adjacent over hypotenuse. Adjacent over hypotenuse, which by ABC parameter, this is where we have our adjacent and this is our hypotenuse, which will be A over C. The next one we have is the tangent. So tangent theta, or we call it in short form tan theta, this will be equal to, what is the side we have here? From the trigonometrical identity, opposite over adjacent. This is our opposite and this is our adjacent. So that will be opposite over adjacent, and that will be, okay, that will be B over A. All right. So these are the three basic trigonometrical identity. The next one we're going to look into is going to be the inverse of each of these ones we have listed already. We're going to look at the inverse of them and what the outcome will be like in the next slide. So